Good morning friends. Today we are going to start with another topic of this textbook, that is the quadratic equations, right? So I think you all might have heard about what a quadratic polynomials are in chapter number 2, the polynomials, right? In the recent topic we also studied about a pair of linear equation in two variables. Now we are going to start about the quadratic equations. So first of all, let us discuss what a quadratic polynomial was. Quadratic polynomial, as we all know, a quadratic polynomial is a polynomial which has a degree 2, right? So let me write any example of a quadratic polynomial, that is 2x square plus 4x plus 1, right? This means that this polynomial has a degree of 2 because the highest power present here is 2. So this is a quadratic polynomial. Now when this quadratic polynomial is equated to 0, that means if I say that if p of x is equals to 0, then this given quadratic polynomial, that is 2x square plus 4x plus 1 is equals to 0, will now become a quadratic equation, right? So this is a quadratic polynomial and this polynomial will now become a equation. So what can you say about this quadratic equation, friends? That a quadratic equation is simply an equation which has a degree of 2. Again, let me remind you that the term with x square will have a non-zero coefficient. The term with x square, that means here in this equation I am having 2x square. The term with the x square will have a non-zero coefficient, that means the coefficient of this term will never be 0. If it becomes 0, then this won't be a quadratic equation, it will change to the linear equation or a linear polynomial, right? So discussing about the quadratic equation, I can say that a quadratic equation is simply an expression of mathematical terms having the degree 2, right? It is simply an expression of mathematical terms having degree 2. So in general we can write down for a quadratic equation that the general form of a quadratic equation, this QE simply means a quadratic equation, is ax square plus bx plus c equals to 0. So we have already discussed this, ax square plus bx plus c equals to 0. So as we were discussing, the general form of a quadratic equation is ax square plus bx plus c is equal to 0. Note that, friends, this equation we have already discussed this in chapter number 2, that were the polynomials. In that polynomials chapter we had a topic of a quadratic polynomial, so that is quite relevant to that one, that ax square plus bx plus c, without this equal to 0 we can say that this is a quadratic polynomial, but when this becomes equal to 0, that becomes a quadratic equation. So that is the general form of a quadratic equation, ax square plus bx plus c is equals to 0. You need to remember this. Again, the condition must be that a is not equals to 0. A is not equals to 0, that means the coefficient of x square here present in this equation will never be equal to 0. Note that, friends, if this becomes 0, then what will happen? So I am having an equation here that ax square plus bx plus c is equals to 0. If I say that if a is equals to 0, then this will become bx plus c is equals to 0. This is no longer a quadratic equation, but this has now become a linear equation, right? Because there is only one variable present here and that has a degree 1 or that has a power 1. So you can say that a quadratic equation will be always having its coefficient of x square as a non-zero term or a non-zero constant, right? You might well note that. So that has become the general form of an equation. Again, you might notice that in the previous chapter, that were the linear equation in two variables, the pair of linear equation in two variables, right? There we had two variables. Now again we are dealing with such equations which has only a single variable present here. So it is an expression of mathematical terms having the degree 2 and only one variable, right? So you might say that a quadratic equation will always have a single variable present in it. There will never be two variables present in a quadratic equation at the same time. If that happens so, then that will no longer be a quadratic equation. So friends, note that a quadratic equation has a general form ax square plus bx plus c is equals to 0, where a is not equals to 0. Now, after seeing these general form or the general topic, the introduction about the quadratic equation, we might now come to the topic where you might learn how to form a quadratic equation, right? Let me say, for example, you are having a condition here that the sum of two numbers is 30, and given that the product of them is 200, right? Sum of two numbers is 30 and given that the product of them is 200. So you might come with two numbers first of all, right, such that their sum is 30 and the product of these two numbers is again 200. So friends, here you might come with a condition that there are two numbers. So sir, what we are going to do? We are going to deal with two variables or not? No friends, we are not going to deal with two variables, but in fact for easiness we are going to take two variables such that they will represent the condition perfectly. But again, while solving them, we are going to deal with only a single variable, that is x or y, rather than what we have taken in the conditions, right? So let me take for example first of all perfect one, that there are two friends here, or let me start with a very simpler example, that the product of two consecutive numbers, the product of two consecutive numbers or let me say two consecutive positive numbers or integers is 306, right? So you need to represent this condition in the form of a quadratic equation, right? So again we are dealing here with two consecutive positive integers. So the solution goes like, let the first positive integer be x, right? I'm taking the first positive integer be x, that means my second integer be y. You will say that this is y. No, that won't be y, because here we are taking consecutive positive integers. Consecutive, that means one after the other one. For example, if I say 1 2, they are consecutive, 2 3, they are consecutive, 3 4, they are consecutive, 4 6, they are not consecutive positive integers, but they are actually consecutive even positive integers, right? So friends, note that if I have taken the first integer be x, then the second integer will be x plus 1. right? Why x plus 1? So if I'm taking for example 1 as my first integer, then my second consecutive integer, that means the next consecutive integer is 2. That means in a difference of 1, 1 plus 1, that is 2. Again, if I'm taking 2 as my first integer, then 3 will be my consecutive integer. So 2 plus 1, 3. That means if I'm saying about the consecutive integers, then we shall always take the first one as x1 and the second one as x plus 1. Note that this happens only when there are consecutive positive integers. Sometimes there might be a question like even consecutive integers or odd consecutive integers or anything like that. So in that case we are going to deal with a different condition and a different variable, right? So here the first first positive integer is x and the second integer will be x plus 1. Now the product of them, therefore according to the condition x into x plus 1, that is 306, that means number first and the second number has a product of 306, therefore x square plus x is equals to 306 and hence x square plus x minus 306 is equals to 0. Right, so that is how a quadratic equation is being formed here. So this is our required quadratic equation, is the required quadratic equation, right? X square plus x minus 306 equals to 0. Rather than solving them right now, first we are going to look at only those sums in which we can form the quadratic equation. So first of all, let us learn how to form a quadratic equation and then we shall try to solve them. I know that you might have already studied in standard 9 that how to solve a quadratic equation, how to factorize them, how to solve it by different methods. So rather than doing that, we are going to first learn how to form a quadratic equation, right? I'm having one more example with me here, that John, there are two friends, John and Jivanti, has 45 marbles in total, right? They have 45 marbles in total. Both of them lost 5 marbles each. And the product of the remaining marbles with them now is 124. So again we are going to represent this in the form of a quadratic equation. Let me repeat it again. John and Jivanti has 45 marbles in total. That means both of them has a total of 45 marbles. So it might be like 20 marbles are with John and the remaining 25 are with Jivanti. 25 marbles are with John and the remaining 25 with Jivanti. So in many ways you can discuss this, like how many marbles will they have in total as a 45. Both of them lost 5 marbles each and the product of the remaining marbles with them now, that means the number of marbles they are having after losing 5 each is 124. So we need to represent this quadratic equations, right? Sorry, this in the form of a quadratic equation. So first of all, let us see, let the marbles present, or let the marbles with John, not present, let me write down, let the marbles John has be x, let the marbles John has be x, therefore the marbles Jivanti has will be dash. So what do you think about this? How many marbles will Jeevanti has if John has X marbles. So for this you need to understand the condition that John and Jeevanti total has 45 marbles. So let us say that John plus Jeevanti total has 45. We assume that the marbles that John has is X. So X plus Jeevanti is now 45. So the marbles with Jeevanti will be 45 minus X. Whenever you are given a total, a sum, addition, anything like that, so you will always assume the first one, the first condition as X, so that the second condition will always be total minus X. Note that this will always be the case, right? Whenever you take, in this case, let us see, the marbles that John has is X. We have assumed that the number of marbles the John has is X. So in case of Jeevanti, the number of marbles Jeevanti has will be total minus the number of marbles that the John has. Yes or no? Suppose we are two friends, right? We are having a total of 50 rupees, both of them. The total of both of them money is 50 rupees. I say that let my money be X, so the other one will have obviously 50 minus X. That means whatever the money I possess will be subtracted from the total money, and that will be equals to the money the other one has. So in the same way we are having the number of marbles with Jeevanti or Jeevanti has will be 45 minus X. So this is the original condition. Now what they are having is they are losing 5 marbles each. That means 5 each from John and Jeevanti will be subtracted, because they are losing, they are not gaining, right? Therefore, after losing 5 marbles each, marbles present with John is X minus 5, right? Because he is losing 5 marbles. So what he had first X, now he will be having X minus 5, and that Jeevanti has is 45 minus X minus 5, right? 45 minus X was in the first case. Now she is losing 5 marbles, so the remaining will be 40 minus X. Yes or no? So this is the conditions when John has marbles X minus 5 and Jeevanti has marbles 40 minus X after losing 5 marbles each. Now according to the given condition, the product of the remaining marbles, these are the remaining marbles, right? So the product of the remaining marbles with them now is 124. So therefore according to the condition, X minus 5 into 40 minus X is 124 here. So we can solve it. Let us simplify it. That is 40x minus x square minus 200 plus 5x is equals to 124. So let us take everything on the other side. That will become x square 40x plus 5x, that is minus 45x plus 324 is equal to 0. So that is our required quadratic equation, right? That is our required quadratic equation. So these are the two cases where we can just form our required quadratic equations, right? I'm having one more sum here with me. Let us discuss it, and then I shall give you one more sum in your homework. That means you can solve it by yourself and see that are you getting the answer or not, right? See friends, there is no purpose of watching this video and simply sitting, right? You need practice while solving this math. So I would prefer that you take a pen and paper while watching this video and note down the important points that I am dictating or that I am speaking here, right? Because it will be helpful when you want to revise this chapter, right? It will be helpful when you want to revise this chapter. It will also be helpful when you are going for the practice session. Next one I am having is the area of a rectangular plot is 528 meters square. The length of the plot is one more than twice its breadth. So form a quadratic equation for this condition. The area of a rectangular plot is 528 meters square. So here, as the plot is of rectangular shape, the area of rectangle that we have already discussed in the previous years is simply length into breadth. And the second condition, the second statement says that the length of the plot is one more than twice its breadth. That means if you understand this condition, length is directly dependent on the breadth, right? Length is directly dependent on the breadth. That means if breadth changes, then length is also going to change. So in this kind of conditions or in this type of questions, we will always assume the variable as the thing that is directly dependent on the other one. So as the length is one more than twice its breadth, so if I assume breadth as x, then I can get the length of this plot, right? So let the breadth of the plot be x meters. Let the breadth of the plot be x meters. Therefore, length of the plot is dash meters. Right, length of the plot is dash meters. So I need to fill up this blank here. Understand that length is one more than twice its breadth. So what is twice? First of all, breadth, and one more than that means add one to that, right? One more than this, one less than this, 5 less than this, less than 5 of this. This all needs to be understood clearly. So again, twice its breadth, that means first of all we shall twice the breadth, that is 2x, and one more than this, that means again we shall add 1 to this. So finally you can say that the length of the plot will be (2x plus 1 meters). Right, the length of the plot here will be 2x plus 1 meters, right? So we got the length and breadth in the form of our variable. Therefore, according to the given condition, we can say that length into breadth is equals to area. Therefore, 2x plus 1 into x is equals to 528. Therefore, 2x square plus x is equals to 528, and hence finally 2x square plus x minus 528 is equals to 0. Right, so this is the required condition where we get our quadratic equation, that is 2x square plus x minus 528 is equal to 0. Right, so this is our required quadratic equation, that is 2x square plus x minus 528 equals to 0. So I think this might be clear with you now that how to form a quadratic equation, right? One more thing I am having is Rohan's mother is 26 years older than him, and the product of their ages is 3 years from now is 306. So we need to again form a quadratic equation for this case. Now understand the question first of all, friends, that Rohan's mother is 26 years older than him. That means age of mother is in direct relation with the age of Rohan. Yes or no? So what if I assume the age of Rohan as x, then I shall get the age of his mother, right? So friends, we shall assume that let the present age, because this needs to be written here because there is another condition, that is 3 years from now. From now, that means from the present situation, right? So the present age of Rohan be x years, therefore the age of his mother will be x plus 26 years, right? Because his mother is 26 years older than him. That means the age of Rohan plus 26 years will become the mother's age. Obviously our mother is elder than us, right? So the age of his mother will be x plus 26 years. Now the condition comes that the product of their ages 3 years from now. So first of all we will require this 3 years from now. Therefore after 3 years, or after 3 years, the age of Rohan is now x plus 3 years, and age of his mother, that will be again x plus 26 plus 3, and that is x plus 29 years, right? So after 3 years the Rohan's age and his mother's age are x plus 3 and x plus 29 years respectively, right? Now coming to the condition that the product according to the given condition, what can I say is the product of their ages 3 years from now, that is 306, that is x plus 3 into x plus 29 equals to 306. Yes or no? Yes. Let us multiply them. That will give me x square plus 29x plus 3x plus 87 equals to 306, right? So taking that 306 on the other side, that will give me x square plus 32x plus 87 minus 306 is equals to 0. Solving this 306 minus 87, that will give me that will give me 219, and hence our equation leads to x square plus 32x minus 219 is equals to 0. Right? So this is our required quadratic equation, or this is the equation by which we can represent the given conditions in the form of a quadratic equation, that is x square plus 32x minus 219 equal to 0. Is it clear, friends? Yes or no? Okay. Now, in this way, or these are the examples how you can see or how you can form the quadratic equation. So this is the first topic of this chapter, that is quadratic equations and forming of quadratic or formation of quadratic equations from the data given to you. Right? Now, after we learn how to form a quadratic equation, now we are going to learn about how to solve them. Right? So before trying to solve these quadratic equations, let me say that can we represent these all the conditions graphically? Yes or no? Yes, right? So what will be the nature of the graph that these quadratic equations will represent? Obviously, yes, you might come with an answer that, sir, the graph will be of a parabolic curve, right, or parabolic nature. So the quadratic equations will always be parabola. How? Graphically. A parabola in a graphical representation. So we are not going to see the graphical representation here. We are going to move further with the solution of the quadratic equations and how to find out the solution of any of the quadratic equations given to you. Right? Now, in this chapter, the first topic was the quadratic equations, the general introduction. The second topic was the formation of quadratic equations, and now coming to an important topic of this chapter, that is solution of a quadratic equation. Solution of a quadratic equation basically means to find out the roots of the equations, right, or equation. Roots of the equation basically means to find out the value of the or values of the variable. As this is a quadratic equation, this equations will have at most, or you can say exactly two values of the variables present in here in the equation. So there will be two roots present to you in the equation, and if these roots are the solution to the given equation and satisfy, then they are our values of the variable. That means they are the valid values of the variable that satisfies the given quadratic equation. This is exactly same as that we were finding out the zeros of a quadratic polynomial. Right? In a quadratic polynomial, what we were doing is we were letting p of x is equals to 0, and then we were factorizing them. Once we get the factors, we find out the values of the variable, and hence they were the zeros of our polynomial. Right? The same way, but there is only a slight change, that here we are not letting p of x equals to 0, because here it is already 0 in this case. So this is exactly same as that we did for the zeros of a quadratic polynomial. So without making much ado of this, let us directly come to the methods of solution of a quadratic equation, right? There are some 3 methods of solving a quadratic equation that is given to you in this book. The first one is the factorization. Factorization method. Factorization method, that means to make factors. Make factors such that by splitting the middle term as that of the product of first and last term. Right? By splitting the middle term as that of the product of the first and the last term. Now you might come with a question that, sir, what are these middle term, first term and last term? So we have discussed the general form of a quadratic equation before, that a quadratic equation generally can be written as ax square plus bx plus c is equal to 0. Right? In this equation, ax square, that is known as the first term, right, that is known as the first term, bx, that is known as the middle term, and c is known as the last term, right? So the term with the variable x square, or the expression with the variable x square, is known as the first term, with that of x is known as the middle term, and that the c, the constant term, is known as the last term of the quadratic equation, right? So we are going to split the middle terms, right? Sorry, not terms, term. We are going to split the middle term such that it can be represented as a sum or difference of the factors that we get for the multiplication of first and last term. So this might be a little tough one for you to understand that what I am speaking is. Again, let me repeat. This method leads to splitting the middle term such that it can be represented. It can be represented as a sum or difference. Sum or difference, that means it can be represented as an addition or subtraction of the factors that we get by the product of first and last term. Is it clear or not? So let me take an example, that is 2x square plus 5x minus 3 is equal to 0. This is the first example I am having. Sorry, I made a mistake here by the sign. So friends, you will again make a note that while writing down the question from the textbook or from the paper in the examination, you make sure that you are writing the question perfectly as given in the paper or textbook, right? Sorry. If it is not there perfectly, there might be chances that you get the wrong factors or you might get the wrong answer, right? So again, coming back to this question, the question is 2x square minus 5x plus 3 is equal to 0. So we shall split this middle term here, but first of all, as I said, the middle term will be splitted such that it is represented as the factors which we get as the product of first and last term. So first of all, what we are going to do is, see, I am going to show you in only one sum, then we are going to move further with the official thing, right? So we are going to multiply this, that is 2 into 3. What is this equal to? 6. Now again we are going to split this 6 such that the addition or subtraction must be equals to minus 5. Note that the sign of 2 and 3 are both plus, right? 2 and 3 are both plus. That means the factors we get here must be minus or plus. I'll talk to you later on this. I'm having a table of this, that how to remember that what the factors are, what not the factors are. So again I'm going to split the 6. So first of all, let us mention down all the factors of 6. That is, I think 1 into 6 is 6, 2 into 3 is 6, 3 into 2 is also 6, and 6 into 1 is also 6. Is it clear, friends? Now see, what can I write here is, can I write both the factors as minus or both the factors as plus? No, right? I think the factors must be minus plus or plus minus. Neither of them. Both the factors must be minus because the last term is plus. So if I say that both the factors are minus, so in which case you get the answer as minus 5. I think you might say that. So in this, so if I add this both, now minus 1 minus 6, that leads me to minus 7, minus 2 minus 3, that is minus 5, minus 3 minus 2, that is minus 5, and this is again minus 7. That means our required factors are minus 2 and minus 3. Yes or no? So after writing down this, I shall come back to this question, that the factors here are 2x square minus 2x minus 3x plus 3 is equal to 0. Now you can look here is minus 2 into minus 3 is 6, right? Minus 2 into minus 3 is 6, and minus 2 plus minus 3 is minus 5. So both the conditions are being satisfied here. So now we can get the common factors here, that is 2x is common into x minus 1, here minus 3 is common into x minus 1. So the main thing for the factorization here is the term that you get after taking common from the first and second term is exactly same as the term that we get after taking minus 3 common in third and fourth term. So the factors here, x minus 1 and x minus 1 must be same. Don't make it same, right? Don't make it same forcefully. It might be same, it might not be same. Sometimes there will come a condition that you might have taken wrong factors, and you know that the factors must be same. So what you will do? You will write it down as it is, right? But that will give you the wrong answer. So mind well, the factors must be proper. So you are going to remember this procedure and then factorize. So this is equal to 0 now. Therefore the common factor x minus 1 into 2x minus 3 equal to 0, and hence you can say that x minus 1 equals to 0 or 2x minus 3 equal to 0. Let me write down and in place of or, right? That means either x equals to 1 or x is equals to 3 by 2, right? So this both are the values of x right now for us. You can simply check by putting these values in this equation and see whether the equations are getting satisfied or not. It will be satisfied, and if that is satisfied, that means the solution of the given quadratic equation is x equals to 1 and 3 by 2. That means the roots of the given quadratic equation is 1 and 3 by 2. Is it clear, everyone? The roots of the given quadratic equation is 1 and 3 by 2. Okay friends, so that is about the first one. Let us solve one more sum here for you, so that you might come to know that how exactly it is being solved. So again I am having a quadratic equation, that is 6x square minus x minus 2 is equal to 0. So now solving this, again we shall follow the same method, but now we are not going to do, see, this process here that I have done is just for you to understand. This is not to be done in the examination, right? You are going to start directly from here to here. That means this process is not to be done in the examination. You can do it, but in the rough work at the back of the question paper or wherever the space you get. But it is not compulsory to be shown in the examination, right? So you are not going to show this in the examination. You are going to simply get the factors and solve the quadratic equation. So again, 6 into minus 2, that is minus 12. and I need all the factors. So you will recall minus 12 can be written as 3 into 4, 6 into 2, 12 into 1 and so on. So I am getting a factor like 3 into 4, that is 12, and minus 4 plus 3 is again minus 1. Therefore 6x square plus 3x minus 4x minus 2 is equal to 0. Right? So you will note that 3x minus 4x is minus x here. Is it clear or not? 3x minus 4x, that is 3 minus 4 is minus 1, and 3 into minus 4 is again minus 12. So we got both the conditions satisfied. So you can take out 3x common, that is 2x plus 1, and here you can take out 2 common, that is 2x plus 1 again, which is equal to 0. So the factors here is the common factor 2x plus 1 into 3x minus 2 is equal to 0. That means either 2x plus 1 equal to 0 or 3x minus 2 is equal to 0, and hence you get the values of x as minus 1 by 2 and 2 by 3. Right? So the values of x, the roots of this equation, the solution to this given quadratic equation is minus 1 by 2 and 2 by 3. Is it clear, friends? So this is the required solution of the quadratic equation. Now here we had two different kinds of example. In this example, if you notice clearly that middle term is minus and the last term is plus. Here in this example you might come to know that middle term is minus and the last term is also minus. So note the difference in the factors, friends. In this we had middle term minus and last term plus, that means both the factors were minus and minus. Here we had middle term minus but last term is also minus here, so we had the factors as plus minus and minus for the bigger value. Right? So coming back to a conclusion from this, that this is an important conclusion, friends. So let me erase this one and I am going to write it down here, that this table, you must note down this table in the textbook or in a place where you can easily look up. Right? Middle term, last term, and the factors. Middle term, last term and the factors. The middle term, that means the sign of the middle term, sign of the last term, and the factors that we get. So if the middle term is minus and last term is plus, if the middle term is minus and last term is plus, we get both the factors as minus and minus. Note that, friends, again in the first example that we have solved here previously was middle term minus and last term plus. So we will have both the factors as minus and minus. So the next thing is, if I am having middle term minus and last term is also minus, middle term is minus and last term is also minus, in this case I shall have both the factors as minus plus, as minus and plus, but this minus sign will be of the bigger value. The minus sign is of the bigger term or value. Right? The minus sign is of the bigger term or bigger value. Note that minus plus comes to a relation when this minus here, this minus is due to the minus of the middle term. Right? So that is minus of the bigger term or bigger value. Again, if I am having both the condition as minus plus, that means middle term is now plus and last term is now minus. So in this case I shall have the factors as minus plus minus, and again the bigger value will be plus. Is it clear, friends? Everyone? Right? So if the middle term is plus and the last term is minus, then the factors will be plus minus and the bigger value or the bigger term will be plus. Right? Yes. And the last one, if middle term is plus and last term is also plus, then it is the easiest one, that is both the factors will be plus plus irrespective of the bigger value or the smaller value. That means both the factors that we get here will be plus and plus. So this is an important table that is to be understood, or that is to be remembered when you are going to factorize. Is it clear? See friends, this table you will not get anywhere in the textbook, neither in any of the reference books, right? This is prepared by me and me itself, so you can take a look and you can solve any examples related to this table, and you can check whether you are getting a factors like this or not. If it is not getting, I may have a mistake, but it will be getting, because I have verified it for each and every examples that can be solved by the factorization method. Note that friends, this is used for factorization method only. Rather than using it for the factorization method, you can also use it for the different other two methods also, but there you might not get direct factors, but you can understand that one will be negative, positive, positive, negative, or anything like that, right? So this is an important one to be remembered, that is middle term is minus, last term is plus, the factors are minus minus, middle term minus, last term minus, the factors are minus plus, with minus as the bigger term or bigger value. If middle term is plus, last term is minus, then again the factors will be plus minus with the bigger term or bigger value as plus. And if middle term is plus and last term is also plus, then the factors will be plus plus. Is it clear friends? So you might note down that one. Okay, now we are going to move further with some more examples of the same kind, that is the factorization method. See, I am having a complicated one, that is 3x square minus 2 root 6x minus 2 is equal to 0, right? So that is 3x square minus 2 root 6x minus 2 is equal to 0. Note that friends, here again middle term is minus, last term is also minus, that means the factors will be minus plus with the bigger term as minus. Good, with the bigger term as minus, and we are going to factorize this. So first of all, again multiply first and last term, that is 3 into 2. 3 into 2 is 6, and you are going to look for such factors. Now you are going to look for the factors in somewhat a different manner. So how can you factorize 6? That is 3 into 2, 6 into 1, 1 into 6, 2 into 3. Another, yes, the factors can be root 6 and root 6 also. Note that, because any real number, any composite number, or any number can be represented as a form of irrational numbers also, right? We have already studied this in the first chapter, that any number here can be represented as the product of its irrational number also. That means root 6 is an irrational number here. Yes or no? So this is an irrational number. You can also represent this 6 as root 6 into root 6. So now we are going to get the factors here, as there is only a factor root 6. So you can represent it like, that is 3x square. Here what you are going to write down? Minus root 6, right? 3x square minus root 6x minus root 6x minus 2 is equal to 0. See friends, here it might be plus 2. right? 3x square minus 2 root 6x plus 2 is equal to 0. So it is now getting the factors. So what can you take common here? So can I write this root 3 as 3 as root 3 into root 3x square minus root 6 as root 2 into root 3x minus this again root 6 as root 2 into root 3x plus root 2 into root 2 is equal to 0, right? See, I have written all the numbers in the form of square roots. That means 3 as root 3 into root 3, 2 as root 2 into root 2, root 6 as root 2 into root 3, right? So now you can take out common from this first and second terms. What can you take common? Root 3x can be taken common. So that will lead root 3x minus root 2. Again, I am going to take minus sign common. And root 2 is also common. That will give me root 3x minus root 2 is equal to 0. Yes or no? Therefore, the common factor root 3x minus root 2 into the factor root 3x minus root 2 equal to 0. You might note, friends, that both the factors that we got here are same. Right? Both the factors that we got here are same. Therefore, root 3x minus root 2 equal to 0 and root 3x minus root 2 equal to 0. Therefore, what we can write down now is x is equals to root 2 by root 3 and root 2 by root 3. So, the roots, the solution to this given quadratic equation is root 2 by root 3 and root 2 by root 3. That means this equation is a perfect square in itself, right? Root 3x minus root 2 whole square also can be written, right? So this is a perfect square in itself. Again, let us take one more example. 2x square plus x minus 300 equal to 0. It is quite an easier one. Very easy, I think. So you might know that the middle term here is plus and the last term is minus. Again, that is of the kind where we get the factors as plus minus and plus for the bigger value. So what is the factor? First of all, 2 into 300, that is 600, and I need the factors of 600. I need the factors of 600. Are you getting it or not? Right? So first of all, we are going to multiply the first and the last term, that is 2 into 300, that is 600. So factorize 600 such that you get the subtraction as 1. I think that is 25 into 24. Is it so or not? Yes, it is. Therefore, 2x square minus 24x plus 25x minus 300 equal to 0. Yes or no? You can see, check it out. 25 into 24, that is 600. And you can also see that 25 minus 24 is 1. Therefore, you can take out 2x common, plus here 25 is common. Therefore, x minus 12 into 2x plus 25 equal to 0, and hence x equals to 12 and minus 25 by 2. Is it clear, friends? So, you can see that the solution to the given quadratic equation or the roots of the given quadratic equation are 12 and minus 25 by 2, right? So this is how you can factorize, this is how you can see, this is how you can check whether the given factors are the factors of the given quadratic equation or not. You can also verify them by putting it in the equation. Solve this one for now, that is x square minus 3x minus 10. The simplest one of today's lecture, that is x square minus 3x minus 10 is equal to 0, right? So you need to factorize this first of all. 10 into 1, that is 10. As middle term is minus and last term is also minus, so the factors will be, yes, minus plus, but minus for the bigger term. That is 10 can be factorized as 5 into 2. That means x square minus 5x plus 2x minus 10 is equal to 0. Hence you can take out x common, that is x minus 5 plus 2 into x minus 5 is equal to 0. Therefore x minus 5 into x plus 2 equal to 0, and hence x is equals to 5 and minus 2, right? X equals to 5 and minus 2. See friends, you can directly write it down like this also from here. I have skipped a step from this, that x minus 12 equal to 0 and 2x plus 25 equal to 0. That means x equal to 12 or minus 25 by 2, and here also 5 and minus 2. See that friends, this kind of sums are being asked in the examination for only 1 or 2 marks. So rather than wasting much time on this kind of questions, we shall utilize our precious time in solving such questions which gives us more marks, right? But it is also compulsory and it is also necessary to understand this kind of questions also, that whenever a paper setter comes to an easier level, you might also know each and every fact of this concept or of this chapter, right? Let us see that this is again an interesting one. Root 2x square plus 7x plus 5 root 2 is equal to 0. Note that friends, here we are having middle term as plus and last term is also plus. So the factors obviously will be plus plus, right? The last one of the table that we have written over there, plus and plus. Now what will be the factors here first of all? Can anyone say what will be the factors? The factors will be 5 and 2. How? Multiply the first and last term here. So that will be root 2 into 5 root 2. That becomes root 2 into root 2 is 2 into 5, and that is 10. So now we are going to worry about this 10. I need the factors of 10 such that the addition of both the factors is 7. Obviously that is 5 and 2, right? So you are going to write it down like root 2x square plus 2x plus 5x plus 5 root 2 equal to 0. Yes or no? Right? Root 2x square plus 2x plus 5x plus 5 root 2 equal to 0. Therefore what you can take out common here? So first of all you need to write it down in the root form. Therefore you can say that root 2x square plus 2 is root 2 into root 2 x plus 5x plus 5 root 2 equal to 0. Now you can take out common for those who don't understand. Root 2x into not root 2 again, I am having only x plus root 2 plus you can take out 5 common into again x plus root 2 equal to 0, right? Therefore the common factor x plus root 2 into root 2 x plus 5 is equal to 0. Therefore you can say that x plus root 2 equal to 0 or root 2x plus 5 equal to 0. and therefore you can say that x equals to minus root 2 or minus 5 by root 2, right? So this is how you can solve. You can get the solution of the quadratic equation root 2x square plus 7x plus 5 root 2 equal to 0. Hence the solution is root 2 and minus 5 by root 2. Is it clear everyone, friends? So these are some of the examples of the factorization method. Okay, now what you are going to do it by yourself is, we have solved I think 4 questions in the previous topic, that means formation of the quadratic equation, right? We have solved some 4 examples there and we have formed the quadratic equation there already in the first topic. You are going to solve them by this same method, the factorization method, right? You are going to solve those 4 equations in your book by the same factorization method, and you are going to get the solution of each of them. Yes or no? How to get this solution of each of them, that we are going to see in the next examples, that is how to solve some data type questions also. Now, there is another question that find 2 numbers the sum of whose is 27 and the product is 182, right? You need to find out 2 numbers such that the sum of whose sum is 27 and the product is 182. So here we are talking about 2 numbers. So let the numbers, or let the first number be x. So as we have discussed in the first topic, here it is said that the sum of the numbers is 27. So if the first number is x, let the first number be x, and so the second number is 27 minus x. Yes or no? How it is 27 minus x? Let us say that the numbers are x and y. For example, the sum of these numbers, that means x plus y is equals to 27, it is said, therefore y is equals to 27 minus x. So if I take x as my first number and y as my second number, right? If I take x as my first number and y as my second number, then the second number is 27 minus the first number. Yes or no? So I have directly written here that the second number is, and so the second number is 27 minus x. Now we got the numbers here, that is x and 27 minus x. Now coming to the condition that their product is 182, therefore x into 27 minus x is 182, therefore 27x minus x square is equals to 182, therefore x square minus 27x plus 182 equal to 0. We shall take both the terms on the other side. Now you need to factorize this 182 such that the sum is 27 because the middle term is minus and last term is plus, so the factors will be minus minus. Okay, so factorize this equation now. I think the factors is 14 and 13. Yes or no? Right, the factors are 14 and 13. Therefore, let us write down like x square minus 14x minus 13x plus 182 equal to 0. Therefore, we shall get x into x minus 14 plus 13 into x minus 14 equal to 0. Therefore, x minus 14 into x minus 13 is equal to 0. Therefore, x is equals to 14 or 13. So, this x here means the first number. Right? Now, we need the numbers, that means if x is equals to 14, then 27 minus x, that is 27 minus 14 is equals to 13, and x is equals to 13, then 27 minus x is equals to 27 minus 13 is equals to 14. Right? Therefore, the required numbers are 13 and 14. So the required numbers are 13 and 14, right? So in this way you can solve the question. So first of all, what we have seen? We have seen that how to form a quadratic equation. Once we get the quadratic equation here in this step, then we are going to follow our factorization method. That means this is a combination of two methods that we have discussed here in this chapter, right? Now, coming to one more question of the same kind, that we are having a question here is find two consecutive positive integers. See, again I am solving of the same kind of sum, that find two consecutive positive integers, sum of whose squares is 365. That is the 8th one. Find two consecutive positive integers, the sum of whose squares is 365. Right? So again we are talking about the two consecutive positive integers. Right? Let the first positive integer be x. Therefore, the second integer will be x plus 1. Right? So the first integer is x and the second integer is x plus 1. Now it is said in the condition that the sum of their squares, sum of whose squares, that means we are going to square them first of all and then we are going to add them. Therefore, I am going to write it down here. Therefore, according to given condition, x square plus x plus 1 whole square is equals to 365. Right? The sum of whose squares is 365. That means sum of the square of first number plus square of second number is equals to 365. Yes or no? So we got this equation here. Let us solve it. Therefore, x square plus 2x plus 1 is equals to 365. X square, that is x square, x plus 1 square, that is x square plus 2x plus 1, which is equals to 365. Therefore 2x square plus 2x plus 1 minus 365 equal to 0. That 365 we are taken on the left side, so let us solve it here. Therefore 2x square plus 2x minus 364 equal to 0. Therefore x square plus x minus 182 equal to 0. Note that friends, this equation is exactly same as that of we have solved in the previous example, just the change of sign and the middle term, right? So again we are going to factorize, that is x square plus 14x minus 13x minus 182 equal to 0. Therefore what we can write down? We can take out x and minus 13 common from these terms, that is x into x plus 14 minus 13 into x plus 14 equal to 0. Therefore x plus 14 into x minus 13 equal to 0. Therefore x is equals to minus 14 and 13. But x equals to minus 14 is not possible, as it is negative, right? X equals to minus 14 is not possible, it is negative. Why? Because we only require the positive integers, so that is not possible. So x equals to 14 is not possible, hence x equals to 13 and x plus 1, that is 13 plus 1, that is 14. Therefore the required numbers are 13 and 14. Is it clear, friends? So the required numbers are 13 and 14. We took both the examples, but the conditions were same and the answer to both the questions were same. Again you can check out, the numbers are 13 and 14, or the required numbers are 13 and 14. Is it clear, friends? Okay, now let us to get one more example of the same kind, and then we shall move on to the next topic or the next method, how to solve a quadratic equation, right? Okay, let me erase this also. Let that be there as it is. The altitude of a right triangle is 7 centimeter less than its base if hypotenuse is 13 centimeter, then find the other two sides. See friends, here we are talking about a right triangle. So in a right triangle we know that one angle of a triangle is always 90, right? One angle of a triangle is always 90, and we are having a hypotenuse also. So if this angle is 90, then this is the hypotenuse. We are given this as 13, and it is said that altitude, that means the perpendicular side, that is altitude, and that is the base. Altitude is 7 centimeter less than its base. That means the length of the altitude is simply dependent on the base. So let the base of the triangle be x centimeter. Therefore the altitude of the triangle is x minus 7 centimeter. Yes or no? Right? Altitude is x minus 7. See, the altitude is 7 less than the base of the triangle. That means base minus 7 will become its altitude. Therefore, according to the Pythagoras theorem, Pythagoras theorem, that means the sum of the squares of the side making right angle is equals to the square of the hypotenuse. So that means x minus 7 square plus x square is equals to 13 square. Right? So let us solve this. X square minus 14x plus 49 plus x square is equals to 169. Take that everything on this side, that is 2x square minus 14x minus 120 is equal to 0. This 169 will come here, that will become minus 49 minus 169, that is minus 120. So you can take out 2 common from every term, that will give me x square minus 7x minus 60 is equal to 0. So the factors are factors of 60 such that you must get 7, that is 12 and 5. Therefore x square minus 12x plus 5x minus 60 equal to 0. Therefore x into x minus 12 plus 5 into x minus 12 equal to 0. Therefore x minus 12 into x plus 5 is equal to 0. Hence x equals to 12 or minus 5. But x equals to minus 5 is not possible. Why? Because the side cannot be negative. Therefore x is equals to 12, right? Therefore x is equals to 12. So we got x is equals to 12. Therefore altitude, therefore base of triangle is equals to 12 centimeter, and altitude of triangle, that is x minus 7, that is 12 minus 7, and that is 5 centimeter. So we got the answer that the base of the triangle is 12 centimeter and the altitude of the triangle is 5 centimeter. So we get base, that is 12 square 144, altitude 5 square 25 plus 144, that is 169, which is again the square root of 13. So in this way you can solve the given example, right, with the given conditions.